So let's start with our first question. The first question states that the diagram shows a blast furnace. Part A states that the following equations represent the reactions which take place in the blast furnace. So here we can see clearly the 5 reactions that are taking place. The first reaction is the production of carbon dioxide by the reaction between carbon and oxygen. Reaction B is an example of is the decomposition of calcium carbonate, which will form calcium oxide and carbon dioxide. Reaction C is the production of calcium silicate, which is a molten slag, by the reaction between calcium oxide and silicon oxide. Reaction D is the reaction of carbon dioxide and coke, the impure carbon, which will form carbon monoxide. And reaction E is the reaction between iron oxide and carbon monoxide, which will form pure iron, pure molten iron, and carbon dioxide. Now, let's look at the first part of the question, which is asking us to find the reaction which is used to increase the temperature inside the blast furnace. So among all these reactions, reaction A is the answer for the part 1, which is the production of carbon dioxide by the reaction between carbon and oxygen. Let me tell you what happens is, so here you can see a similar diagram. Yeah, it's a similar diagram to the figure in the question paper. It's a blast furnace, and you can see here in zone 1. Let's zoom in so you can, yeah. So here you can see in zone 1, the reaction is happening. Carbon will react with oxygen to form carbon dioxide. So hot air is being blown here, and what happens is, let me give you a description of this answer. So firstly, in zone 1, coke is used as the starting material, which is basically an impure carbon. And this impure carbon, what happens when we blow the hot air, the oxygen from this hot air will combine with the impure carbon, will react with the impure carbon, and will form carbon dioxide. And since it is a strongly exothermic reaction, this means it will release a lot of heat energy. Due to this, the temperature of the blast furnace will increase. So we can say for part 1, the answer is reaction A. So I'll be just typing here the answer. So you are thorough with the questions. Okay. Now moving on to part 2 of this question. Which reaction is an example of a thermal decomposition? So you can see here among all these reactions, reaction B is an example of a thermal decomposition. Calcium carbonate, you can see here, is breaking down into calcium oxide and carbon dioxide. But I'll tell you why only reaction B is the answer, because you know what happens here. Firstly, we should know the definition of thermal decomposition. So thermal decomposition is the breakdown of a compound into 2 or more different substances using heat. So you can see here only reaction B represents the breakdown of a single product. All the reactions involve 2 reactants, and it will form a single product or two or more products. But here you can see in reaction B only calcium carbonate is in the reactant side, and it is breaking down by passage of heat, and it will form calcium oxide and carbon dioxide. So we can say for this question, for this part of the question, the answer is B. Answer is B. Yep. Now moving on to the third part of the question. In which reaction is carbon both oxidized and reduced? Okay. So the answer for this question is reaction D. I'll tell you why. Before solving this question, you should know what are the definitions of oxidation and reduction. There are basically 3 definitions, but for this question, in terms of this question, we are looking for the definitions of addition of oxygen and reduction of oxygen. So we can say here, this first definition you should be familiar with for this question. So what happens? Oxidation is the addition of oxygen into an element or a compound, and reduction is the removal of oxygen from an element or a compound. So you can see here what happens in this reaction D. Firstly, you need to compare both the reactant side and the product side. So you can see here in carbon dioxide there are two oxygen atoms, but when it is forming a product, it involves only one oxygen atom. What this means? This means that oxygen is being reduced here. Okay, and in this, for this carbon atom, you can see in the reactant side it is without oxygen, but when it comes to product side, it is forming a carbon monoxide, because oxygen is being added, so we can say it is oxidation. And since both oxidation and reduction taking place in this reaction, so we can say it is a redox reaction. So we can say here reaction D. Yeah, reaction D is an example of redox reaction in which both oxidation and reduction is taking place. Moving on to the part 4 of this question, which equation shows a removal of an impurity from the iron? So the answer for this question is reaction C, which is the production of calcium silicate, the molten slag, which is formed by the reaction between calcium oxide and silicon oxide. Now I'll tell you why this happens. Now if you see where it is forming, yeah, in this diagram you can see the calcium silicate has been collected as a molten slag, which is collected as at the bottom above the molten iron, and they are being separated. They are tapped off separately. So what happens here? I can tell you. So it is this reaction, right? Okay. So what happens? The calcium oxide, which has been formed from the thermal decomposition of calcium carbonate, will react with silicon dioxide. Basically, silicon dioxide is an impurity from in the iron ore to form calcium silicate, which is a molten slag. What happens now? This will melt and collect as a molten slag floating on top of the molten iron. Calcium silicate will melt and collect as a molten slag floating on top of the molten iron. Now they can be tapped off separately. We can get rid of calcium silicate and we can obtain our pure iron. Right, so we can say for this part of the question, reaction C is the answer, right? Okay, so we'll write here reaction C. Reaction C. Moving on to the fifth part of the question, last part of this. Moving on to the fifth part of the question, which equation shows the reaction of an acidic substance with a basic substance? So again, the answer for this question is reaction C. I'll tell you why. Because what happens? Calcium oxide, calcium is basically group 2, sorry, group 2. So what happens is all these group 2, group 1 oxides or hydroxides are basic, and silicon oxide is an acidic, but it is a weakly acidic. So what you can see here, what is happening, and a basic substance is reacting with an acidic substance, it is forming a forming a product called calcium silicate. So here they are already asking about information about, they're asking about us which equation shows the reaction of an acidic substance, the basic substance. So we can see here, so we can state that reaction C is an example of the reaction of an acidic substance with a basic substance. So here we can say reaction C. We are done with A part. Now moving on to B part. Here's the diagram of the blast furnace to help you answer these questions. So the first part of the B part states that what happens here. So what enters the blast furnace at X? So we can just check where is X. So you can see here, I'll show the diagram now. So they're talking about this part, what happens here. So you can see here in this diagram, yeah, so hot air is being blown here, which will react with the impure carbon, and the temperature of the burner furnace will increase. Okay, so and it will pass on to zone 2. The temperature, because of the high temperatures, it will react with more carbon, from carbon monoxide. But it's talking about what happens at X, what enters at X. So we can say we're passing hot air. So hot air is the answer for this part of the question. Guys, let me just simply write my answer, hot air. One mark question. Second part, part 2 states that what leaves the blast furnace at Y. So if you see the diagram again here, Y is here, and I think it's the molten iron because I showed you the diagram here. What happens here? Molten iron is being tapped off. What happens when the reaction in zone 3, the reaction is taking place between Fe2O3 and carbon monoxide, which will form pure iron and carbon dioxide. This pure iron will be collected as will be melted and will be collected in the bottom and will be tapped off separately. But in this part of the question, they are asking only about what leaves at blast furnace at this point. So we can say pure iron. Okay, pure iron I can mention here. Pure iron, yeah, pure iron. Part 3, name two gases that leave the blast furnace. I showed you before the diagram, and I said it also before. What happens in it, basically it involves the gases of zone 1 and zone 2, which is the carbon dioxide and the carbon monoxide. So what, when we are blowing hot air into this part, into the zone 1, and the oxygen from this hot air will react with the impure carbon and will form carbon dioxide, and this will increase the temperature of the blast furnace. So what happens now? And now the blast furnace temperature is increased, so this means that carbon dioxide will react with more carbon, okay, and will form carbon monoxide. So these are both gases that will escape as waste gases. So we can say here two bodies are escaping carbon dioxide and carbon monoxide. Two brothers are escaping from this blast furnace. Moving on to part C, the graph shows how the malleability of iron changes as the percentage of the carbon in the iron changes. Describe how the malleability of the iron changes as the percentage of the carbon changes. So it's a 1 mark question, so you need to mention only one statement. So you can see here they've provided us with the graph. So you can see in the x-axis there's an increasing percentage of the carbon. This means we are increasing the percentage of the carbon, and the result for this is the malleability. So you can see here the line is sloping downwards. This means the malleability is decreasing as we are increasing the percentage of the carbon. But if it was sloping upwards, this would mean that the malleability of iron would increase. So but now it is sloping downwards, so we should mention that it's decreasing. But firstly we need to mention about x-axis. So on x-axis, what we are doing, as we are increasing the percentage of carbon, the malleability of iron decreases. Yeah. Then moving on to second part, iron obtained from the blast furnace contains high levels of carbon. Describe how the amount of iron can be decreased. Explain how the amount of carbon in the iron can be increased. So before we are obtaining the molten pure iron, what happens in zone 3, it contains some of the carbon impurities. So what we are doing, we are passing this hot air is blown, and this will react from the oxygen from this will react with carbon, and it will form carbon dioxide. Okay, so we need to mention the equation also, and we can mention the equation, or either we can say that the carbon dioxide is being formed, and we could also say that, and we should also say that hot air is being blown. We should mention two things, so we'll score 2 marks here. So I can say 1 minute, yeah. Carbon dioxide. Oh, sorry, mostly hot air. Hot air is blown, which will result in reaction of carbon and oxygen forming carbon dioxide, which will escape as a gas. Yep, done. Okay, and we are done with this was the end of the first question. Moving on to the question number 2. The structures of 6 organic compounds are shown. So here we can see clearly all the 6 structures of the organic compounds. The first part of the question states, give the name of F. Compound F, so you can see here clearly. So how will name this compound? Now there are 2 rules. Firstly, you should identify whether they are carbon single bonds or carbon double bonds. Carbon single bonds or double bonds will decide the last ending name of the organic compound. For example, if it is a single bond, it will end with "ane". If it is a double bond, it will end with "ene". And the carbon atoms, the number of carbon atoms will decide what will be the first part of the organic compound, name of the organic compound. So here we know that if there was 1 carbon atom, we will call it meth. If it was 2 carbon atoms, we'll call it eth. If it was 3 carbon atoms, we'll call it prop. But now if it is 4 carbon atoms, we'll call it but. So we know the first part of the organic compound, but, and we know it is single bond, so ane. So our organic compound will be butane. The name of the organic compound will be butane. 1 minute, guys. Let me just align it properly. You can see the answer. 1 minute. Butane. You need to be thorough with organic chemistry for these type of questions. Now moving on to the B part of the second question. Identify 2 of the compounds that are members of the same homologous series. Give the general formula of this homologous series. Okay. So if you see among all these structures, there are 2, but I'll mention only one. You can see A and B are the members of the same homologous series. They are the members of the group alkenes. How I identify is by the carbon-carbon double bonds, because the organic compounds which contains carbon-carbon double bonds are recognized as alkenes. So we can say A and B are members of the same homologous series, and you should be familiar with all the alkenes and their molecular formula, and their molecular formula, structural formula, everything. So I'll write here A and B. And you should also be familiar with all the general formulas of all the homologous series. So the general formula for all alkenes is simple, which we say CN CnH2n. This is it. This is the general formula for all alkenes. Great. Now moving on to part C of the question. Part C states which 2 compounds are isomers of each other. Explain why they are isomers. Now, you need to find the compounds that are isomers of each other. So A, B, C, D, E, and F. Okay, so among all these organic compounds, I can say that E and F are isomers of each other because this is represented by the chain isomerism. You need to know, if you need to know more about chain isomerism, you can comment down below, so I can create videos for organic chemistry, and I can explain all the isomerism, position isomerism, structural isomerism, and chain isomerism. I will enable the comments later. Now here we can, moving on to the question, we can say that E and F are isomers of each other. Now let me just write here firstly the compounds E and F, E and F, because you can see here they are both in the group alkanes because they have carbon-carbon single bonds, but You can see what is the difference between these two organic compounds. You can see in F there is a carbon straight chain. There is a straight chain going on, but in this E organic compound, you can see there are three carbon atoms with a single chain, but the fourth carbon atom is bonded to this middle carbon atom. So what we can say here, actually, we can say they have the same molecular formula, but their structural formula is different. This is the reason why compounds E and F are named as isomers of each other. Okay, so we need to write, actually they are asking here, we can write the simple definition of isomers, but we need to create it in a different, create it with different words. Let me just write here 1 minute. 1 minute. Okay, so here you can see the answer for this explanation for this. You can write as this is because they have the same molecular formula but different structural formula. You have to write this as it is. Now then you can move on to the next question, and you can see till now we are going very smooth. Okay, so for scoring full marks in this question, firstly you need to be thorough with organic chemistry, because most children are confused in these type of questions which are related to organic chemistry, and you need to practice it more so you can become an expert in these type of questions. Okay, moving on to part D. Explain why B is an unsaturated hydrocarbon. Let me just go to the structure of the B. So B is an alkene. You can see here B is an alkene because it contains carbon-carbon double bonds. So we know its last ending name is ene, and it contains two carbon atoms. So we know it's ethanol, eth. So we can say the name of the organic compound B is ethene. Now what they're asking, explain why B is an unsaturated hydrocarbon. And you can see here, it's a 2 mark question. So why it's a 2 mark question? I'll tell you why. Because they're asking, explain why B is an unsaturated, okay, unsaturated and a hydrocarbon. You need to explain the reasons for both, why it is an unsaturated hydrocarbon. So unsaturated because all alkene is unsaturated, right? You should know that all alkenes are unsaturated because they contain carbon-carbon double bonds, and alkenes are hydrocarbons because they contains only carbon and hydrogen atoms. Make sure you mention the word only, otherwise you will lose your 1 mark. So firstly, we should mention that B is an unsaturated hydrocarbon because it contains carbon carbon double bonds, and it contains only hydrogen and carbon atoms. Okay, so wait a minute, this question. Great. Now we'll move on to 2E. Let me just, yeah, so 2E, element 2D, so we now move on to 2E. Describe how D is manufactured from B. Give a chemical equation for the reaction. So let me just check what they're asking about, because firstly I need to know what are the organic compounds D and B. They're asking describe how D is manufactured from B. So we are using B to manufacture D. You can see here we are using B to manufacture this compound, and you can see here B, as I told you before, it's an ethene and it's an alkene, right? Okay, so we are using an alkene, which is an ethene, to make this the organic compound D. So how we'll name this organic compound? Now you can see here, before, in all these organic compounds in A, B, and E, F, you can see here they all contain only carbon and hydrogen atoms. But for these, you need to be careful. You need to check whether they have an extra like oxygen atom or any other element they contain. So if now they are only containing ONH group. So ONH group is for alcohol. So we know its last ending name is ol, right? And it contains two carbon atoms. Now we can say if it contains two carbon atoms, it is called eth. Okay, so we should name this organic compound as ethanol. So we are basically manufacturing an alcohol from an alkene. Okay, so this means we are using ethene to manufacture ethanol. Now, if you see the question, describe how D is manufactured from B, you need to get the chemical equation for the reaction. Okay, so firstly, you can, if you see, I have written this, you need to mention all the reaction conditions and the chemical equation, you need to balance it. So we need to be very creative with words here, because, okay, so what we'll do here, we'll write this, a minute, add a text. Okay. We can say ethene, or you can also mention the name, like we can also mention in terms of alphabets. For example, B will react with D. Okay, but I'm writing here to explain you properly. So ethane will react with steam. Okay, need to mention this. I'll show you the chemical equation afterwards, but I'm writing a description now. Ethane will react with steam at a, let me just write the temperature also, let me just note it how much it is. At a temperature of around 330 Celsius, okay, at a temperature of around 330 Celsius, 330 Celsius, and of pressure of 60 to 70 atm, pressure of, 1 minute guys, yeah, sorry, and pressure of 60 to 70 atm in the presence of, okay, so I mentioned temperature and pressure, now I need to mention catalyst. So in presence of concentrated phosphoric acid, catalyst, so it's easy for you to recognize what are the catalysts. What I'm trying to say of catalyst, concentrated phosphoric acid, concentrated phosphoric acid, right? So we have mentioned all the reaction conditions, and we have scored 2 marks here. Now if you okay, so we need to give a chemical equation. Basically we were asked to write only 2 conditions. When I saw the marking scheme, we were asked to only write 2 reaction conditions, but I wrote all of them so you can just clearly see all these catalysts, and if you forget something, so you can use another one. I think you can see probably. And now we'll write the equation for the chemical equation for the reaction of the reaction. So now 1 minute guys, sorry, where's my paper? Yeah, so actually I wrote the molecular formula, but I wrote this I wrote the structural formula here. 1 minute, I'm getting lost. Yeah, now here. Okay, so we need to convert this into the structural formula. Okay, so it should be, so there are 2 carbon atoms, 4 hydrogen atoms, so we'll write this as C2H4. So we'll write here our answer as C2H4, C2H4 plus H2O, is the gas steam, right, plus H2O will produce what? Will produce ethanol. Okay, we can write here C2H5 and OH. Okay, we need to, and OH we need to mention differently, but we need to then we need to take all O is with H, so we'll write it together, but at the last, and we need to mention, otherwise we need to mention all the carbon atoms and hydrogen atoms except for this. We'll write it at last. Okay, so we need to say C2. There are two carbon atoms and five hydrogen atoms here, and we'll write this OH group at the last. So we can write here our answer as, guys, 1 minute. Yeah, C2H5OH, right? Okay, so this is the answer for part E. Moving on to part F, compound A forms an addition polymer. Okay, what is the compound A? Let me just check. Compound A is butene. Why butene? Because but is for the first four carbon atoms, and ene is for the, because it contains carbon-carbon double bonds. Now we need to just make it fast. So compound A forms an addition polymer. Draw two repeating units of the addition polymer formed from A. So I couldn't draw in this PDF file, so I drew it in Word, and I'll show you this answer. Now, firstly, what you need to do when we are drawing the monomer structure, if you get this, 1 minute, guys. When you get this structure, yeah, whenever, so we are basically, it's butene, so how will form an addition polymer? Now addition polymer, draw two repeating units of the addition polymer formed from A. So whenever they ask you to draw two repeating units, firstly you need to break down, you need to only check the double bond. Where is the double bond? Now in this question you can see here, you need to draw only the double bond here. Okay, only the double bond, only this carbon atom and this carbon atom we need to draw, but they're asking for two repeating units, so we'll draw it two times, so there will be in total there will be four carbon atoms. Okay, but this time you need to convert the double bond into single bond. The rule for if you are making an addition polymer, we are drawing two repeating units. Sorry guys. Okay, so don't look at the marking scheme here. I'll explain it properly here. Now, if you can see here, you will convert the double bond into single bond, and you'll get the two repeating units. Okay. Now, you need to draw the structure as it is. You're looking at the hydrogen atoms. Okay. So you can see in this structure, the hydrogen atoms are pointing upwards. Look at this part only. Okay. At this part. No, don't look at the this um, first and last carbon atom. Only the double bond carbon atom you need to focus. You can see the H is pointing upwards. So what you need to do, this was an alternative way I drew. So you need to point all the H upwards. Okay, okay. So and what you need to do, then next what you need to do is, if you see this carbon atom, you can see here there are, now if you convert this into single bond, okay, so it will we know that carbon atom will make four bonds, right? So how we'll do that? You can see here before it was carbon-carbon double bonds, so it make 1, 2, 3, 4 bonds here. But now it's converted to single bond. Now it's only three bonds. So we need to add one hydrogen atom below. So what we'll do here, we need to write this in one thing. Like what I'll show you. So we'll write this car if we for example now this CH3 will come from where? So you know that this carbon atom, there are three hydrogen atoms. You need to include this in the carbon-carbon double bond, which we converted into single bond. Then we included the CH3 here in the first carbon atom. Then we mention H. Okay, then you will convert again. The CH3 will come here from the right hand side. Firstly, we did from the left hand side. Then we'll do from the right hand side. Then this hydrogen atom again. We need to draw hydrogen atoms to complete the four bonds. Now the marks you are getting, the marks you're scoring is based on the whether you are drawing correct carbon atoms, because that they'll look at, if you're not drawing the double bonds, you need to draw single bonds, and make sure you show these continuation bonds. Continuation bonds you need to extend, so they are represented as continuation bonds. Otherwise, the examiner will be confused with your question. You only score 1 mark, and for scoring 2 marks, you need to draw the extended continuation bonds, and the carbon structure should be properly drawn. I hope you're getting it. I'm not good with words. Sorry, guys, for this, but I hope you will get it. Okay, so we are done with it was the end of the second question. Now moving on to the third question. Clean dry air contains mainly nitrogen and oxygen. Part A states that name two other gases that are in clean dry air. So they're asking us to mention two other gases that are in clean dry air. So tell you that. Okay. So apart from nitrogen, they have given us a hint that apart from nitrogen and oxygen, we need to mention two other gases. And make sure you read the question properly. They are not asking for two clean gases. They are asking for two other gases that are in clean dry air. Let me just tell you how is it. You can just look at, you need to know the composition of the air, where you can look at this pie chart here. You can look at this pie chart here. You can see apart from nitrogen and oxygen, we already have nitrogen and oxygen here, 78% nitrogen and 21% oxygen. And this other including, we have, you can see there carbon dioxide present in the clean dry air, and there's argon also present, but it's not necessary to mention only argon. You can mention any named noble gas. For example, you can mention xenon, or you can go to your periodic table, and you can look at the group 8, group 0 noble gases, and from there you can write any one. But I'll prefer writing argon, so I'll write the answer as argon and CO2. Okay, argon and carbon dioxide, argon and carbon dioxide, CO2. B part, air often contains pollutants. Identify three common gaseous pollutants in air and state how each of these pollutants are produced. Now you can see the 6 mark question, and we don't want to lose any mark in this question because 6 marks are of very importance here. Every mark is very of importance, whether it's a 1 mark question, 2 mark question, 3 mark question. Now moving on to the question. Now actually there are four gaseous pollutants, but we'll mention only three. So let me just show you all of them, and we need to mention also the sources. So firstly, you can see here we have carbon monoxide, we have sulfur dioxide, we have oxides of nitrogen, we have compounds of lead. Okay, so firstly I'll talk about carbon monoxide. They're not asking, I have mentioned also the adverse effects and the equation also what will happen, but they're asking us for sources, and they're asking us information limited to sources and the name of the gaseous pollutant. So firstly, I'll say carbon monoxide, and the source is the incomplete combustion of fossil fuels. No need to mention the example because they haven't asked for that. Now, what I will do here, I'll just write it here. So answer for this question, pollutant gas 1, carbon monoxide. Carbon monoxide, and how is it produced? Incomplete combustion of fossil fuels. Okay, you need to be familiar with with the two types of combustions: incomplete combustion and complete combustion. Okay, so we can say here incomplete combustion of fossil fuels. Fossil fuels. Okay, just extend this so you can see properly here. Now it's okay, perfect. Now they're asking about pollutant gas 2, which is sulfur dioxide. Okay, so what is the source of this sulfur dioxide? We have combustion of fuels, natural gas, and sulfide ores. No need to mention the example. So let me just write here. You just copy this. So because otherwise it will take time to write. Okay, so I'll write here. Wait, PDF file. Yeah. So the answer, the pollutant gas 2 is talking about their sulfur dioxide. Sulfur dioxide. And how is it produced? You need to know. Yeah, look, I can answer these type of question in 2 minutes, in 3 minutes, but explaining takes a lot of time. So you are familiar with each and every concept. I hope you're understanding. Okay, moving on to the question. Pollutant gas 3. Pollutant gas 3 is oxides of nitrogen. Oxides of nitrogen. We can also mention compounds of lead, but I prefer writing oxides of nitrogen because I remember it properly. So you can see here the sources are the reaction of nitrogen with oxygen in car engines and high temperature furnaces as a product of bacterial action in soil. So you need to mention this statement, okay, to score full marks. Now I just mentioned this source, okay. Now you can see we have scored 6 marks in this question, right? That's great. Moving on to the fourth question. Okay, so this was the end of the third question. Now we'll move on to the fourth question. Okay, so fourth question, part A, 1. Describe what happens in terms of electron loss and gain when a potassium atom reacts with an iodine atom. So actually there is a bigger description for this. So I'll show you that before I mention the answer. So the answer is highlighted in yellow if you want to write. But firstly, I'll explain you what will happen. So we know that potassium is a group 1 metal. So one, it will lose. Actually, what happens in ionic compound? Ionic compounds usually mainly consist of a metal and a non-metal. Okay, so potassium is a metal and iodine is a non-metal. So it's forming potassium iodide. So what happens here? Potassium is a group 1 metal, meaning it will form a positive ion with the charge of +1. So what happens to form a positive ion? What it will do? It will lose its one electron. You know, it's losing the negative electron. So it will become positive. Okay, so to another atom to have a full outer shell of electrons. What will happen? A positive ion with a charge of +1 is formed. Now, iodine is a group 7 non-metal. Okay, it's in group 7 non-metal. This means it has 7 electrons in its outer shell. And if it is gaining 1 electron, its charge will be negative. We know that. To have a full outer shell of electrons. So what happens? 1 electron will be transferred from the outer shell of a potassium atom to the outer shell of the iodine atom. This means we are balancing both. We are making both of them as a noble gases, but they have a charge, meaning they have the same similar structure to a noble gas. So what will happen? Iodine atom will gain 1 electron to form a negative ion with charge -1. But the answer we are referring as we are talking about only the movement of electrons, as the question states before. In terms of we need to say electron loss and gain. So firstly we need to state that iodine is a group 7 orbital, so we need to gain 1 electron to have a full outer shell of electrons. I think I'm just speaking too fast. Sometimes the tongue slips. Okay, I will try to slow down. Iodine is a group 7 non-metal, so we'll need to gain 1 electron to have a full outer shell of electrons. So 1 electron will be transferred from the outer shell of the potassium atom to the outer shell of an iodine atom. So basically we are mentioning in terms of electron loss and gain. I hope you're getting it. I'll mention this answer here. In total there are 6 questions. So this is your answer. You need to write to score 2 marks. These 2 points are important. Moving on to the part 2, describe the structure of solid potassium iodide. You may draw a diagram. Okay. Okay guys, for this part of the question, I will not show you the diagram for the solid potassium iodide, but I have a similar diagram. Actually, you need to draw that similar diagram, but you need to just you need to just change the ions there. I'll show you that diagram. You know why? Because if you can see here, it's a diagram for a sodium chloride, right? What you need to do, you need to draw this cube you need to draw properly. And you need to, if you're representing the ions, you need to just change that K plus and A plus into K plus, because it will have a similar structure, you know, because sodium is in group 1 and potassium is also in group 1 and Cl minus is in group 7 and iodine is also in group 7. So basically it will have a similar structure. And this description, what they're asking is, basically the description you need to write, it's a lattice, they're forming a lattice structure. Okay, so lattice structure are always formed by these ionic compounds, the group 1 metal and with group 7 halogens. So what we need to state, we need to state that with the lattices formed by the ionic compounds, we need to write the potassium iodide consists of a regular arrangement of alternating positive and negative ions. Basically the 2 marks for a regular arrangement and alternating positive and negative ions, but I am explaining with words so the examiner can understand. Actually, in marking scheme, the examiner has given us some clues like some keywords to write. But how to be creative, you need to be you need to know how to be creative with words. So now I will just copy this question, copy this answer, and I'll write here properly. Now the diagram you need to draw. You may draw a diagram. Actually, there's no need for diagram, but I'll recommend you to not draw a diagram because you need to save your time. Okay, for an exam, there will be no time for this. Moment, guys. Let me just yeah. Now I'll just add text here, and I'll just write it here, the answer for you. Okay. So I need to change this ionic compound into potassium iodide because this mainly now we're talking about potassium iodide. Okay. You can also mention ionic compounds, but I prefer to be specific in these type of questions. Potassium iodide is the answer. Okay. Okay. Now explain. Moving on to part 3. Explain why potassium iodide has a high melting point. Now for this question, this is a very easy question actually. You need to be familiar with all the properties, general properties of the ionic compounds, and I have noted them for you so you are not confused. Okay, there are some properties of ionic compounds have high melting points and boiling points. This is the reason they have given. So basically the ionic compounds have high melting and boiling points. Why? Because this is because the oppositely charged ions in the lattice structure are attracted to each other by the strong electrostatic force which hold them firmly in the place, and hence large amounts of energy are needed to overcome these forces, so the melting and boiling point are high. You need to mention you need to check the mark of the question. It's a 2 mark question, so I'll mention these both points because actually there's no need, because oppositely charged and strong electrostatic forces are is enough to write, but I'll write this also so examiner can understand properly. Okay, so you need to mention this answer. It's a 2 mark question. You need to be also careful if you are writing the written exam. Obviously you write a written exam in your IGCSE exams, and you need to avoid striking too much. Okay, so I think you need to be very careful before writing. You need to just make up that blueprint when you're writing in your mind, and then you need to start construction on that. Okay, now moving on to part B. Potassium iodide and lead nitrate are both soluble. Lead iodide is insoluble. Describe how a pure dry sample of lead iodide could be made from solid potassium iodide and solid lead nitrate. Basically, you are making lead iodide, which is insoluble, and from two compounds that are soluble. So, in preparation of salts, you can check the preparation of salts topic. You need to be thorough with this topic, and need to be thorough also with the filtration topic. So you can just both combine the both things, and you can make your research. So I'll just show you the answer for this. Give me a second. Okay, guys, moving on to the part B. So the part B question. And for writing this, before writing the answer for this question, I need to show you a similar experiment, and you need to be thorough with the experiment. What was the yeah, preparation of salts. You need to be familiar, and you need to be familiar with all the how we'll make an insoluble salt from soluble salts, and how we'll make soluble salt from insoluble salts. You can see lead iodide is the product from this question. You can make up in your mind that lead iodide is an insoluble product. Okay, this means lead iodide is an insoluble product, and potassium iodide and lead nitrate are both soluble, and we are using the reactants to make products. So reactants are soluble, and the product is insoluble. Now, how we'll obtain a pure dry sample? It's a 4 mark question. 4 details are required. Okay, so they are not given any chemical equation to mention. So what we'll do, I'll just show you the a similar equation. Firstly, you need to know. 1 minute, I just re-highlight it 1 minute. So you can see it properly. Color fill white. Yeah, now you can see it properly. I'll make it bold, and I will just increase the size for this. Yeah, now you can see it properly. Now we are making preparation of pure dry. This is a different experiment. Okay, don't copy this. Preparation of pure dry lead to sulfate crystals using a precipitation reaction. Okay, so you can see here we are using two soluble salts, and we are making an insoluble salt. Okay, lead to sulfate is an insoluble salt, and we are using two soluble salts. So firstly, the method you can see here, we have to dissolve lead to nitrate and potassium sulfate in water and mix together using a stirring rod in a beaker. Filter to remove precipitate from the mixture. Wash precipitate with water to remove traces of potassium nitrate solution. Okay, leave in an oven to dry. Potassium nitrate. Let me just potassium nitrate. You can see here. What? Yeah, you can see here when lead to nitrate potassium sulfate is forming. It's a double displacement reaction. Okay, so lead sulfate will form, lead sulfate will form and potassium nitrate will form. So what we need to mention here, there are two soluble salts, right? So we need to just mention this experiment as it is, but we need to replace some words. Let me just copy this experiment into this PDF file, so I can just show you clearly, so you are not confused with this question, experimental questions. Okay, so you can see here dissolve lead to nitrate. Okay, so we have dissolved lead to nitrate, and potassium nitrate is okay here. I can just remove two, so because they are not asking about lead to nitrate, and here I can say potassium iodide. Okay, now you can see here, and mix together using a stirred rod in a beaker. Filter to remove precipitate from the mixture. Wash precipitate with water to remove traces of potassium nitrate. Yeah, potassium nitrate. Yeah. Living on Monterey. This is the experiment. You need to mention 4 details required as it is mentioned, and you are just done. I think you can see clearly. Moving on to part 2, write an ionic equation for the formation of lead iodide, PbI2. This is the chemical formula for this compound. Yeah. When potassium iodide and lead nitrate react with each other, state symbols are not required. State symbols means that there are states, for example, if it's gaseous, if it's solid, if it's liquid. Okay, I'll explain you that. Firstly, the first step is what? Whenever they ask you about ionic equations, okay, so you can firstly you need to check the mark of the question. The 2 mark question, this means you need to balance the ionic equation. Okay, firstly you need to write the chemical equation, but they're asking for only ionic equation, so you need to write it somewhere else in the paper. Okay, so you need to mention this chemical equation. Now what you need to do, if you see here, actually just raise the ions. It will be 2 plus NO3. 1 minute, guys. 1 minute, guys. Okay. Okay, guys. So firstly, what you need to do, you need to write the chemical equation. Then you have to write all the ions present here. For example, Pb2 plus. We have NO3 2 minus. We have NO3 1 minus. We have 2K 1 plus. Then we have 2I 1 minus. Then we have the product side will include Pb2 plus, and so on. We'll write all the ions present in this. Now, listen to me carefully. You need to you need to compare both the reactant side and the product side, and you need to cancel out the same ions. Okay, not with opposite charges, the same ions you need to cancel out. Now you can see here, if I see here, NO3 and NO3 is common, right? Yeah, it's common. So what I need to do, I need to just delete them. Yeah, delete them. Okay, I'll just delete them. Yeah. Now what else ions I have? I can see here there's one ion left in this reaction with both products and the reaction side, and I will just kick out this ion from here. 2K1 plus is present in both reactant and product side, and now you have constructed you have the you have firstly created the blueprint of the map, and now you have created the building. Your building is ready. You can just now give a final touch by writing this in the PDF file. Okay, this is the answer for this question. Okay, now moving on to part C. When chlorine gas is bubbled through an aqueous solution of potassium iodide, a redox reaction takes place. What is a redox reaction? Redox reaction means that both oxidation and reduction takes place at the same time. State the color change expected in this reaction, star color and N color. So you need to be familiar with the colors of the halogens in solutions, and if they are individual, you need to know the color, and you need to know the color of also the group 1 compounds. Okay, so all group 1 compounds are colorless. Okay, this is the statement you need to know. Okay, you need to know this statement. What we can write here, start color was colorless because we had this potassium iodide. Okay, you need to I always tell my friends and students to read the questions carefully before you answer it. At least read them twice. Okay. But by understanding the question, not just simply reading and not getting anything. Okay, so we can state the color as colorless, initial color, colorless, and final color and color. You can see here a redox reaction takes place. You can see here iodine gas is produced, but it's with a solution. Iron gas and chloride ions are present. Okay, so what you need to mention the color and solution. You can see here there are two columns given here. You can see the color and the color in solution. Now, iodine, you need to check for the color in solution because you can see the ions that are present. The Cl minus ion was present. If it was alone, you can mention black, but now if it's in solution, you need to mention the color of iodine in solution. Now I'll mention here dark brown. Okay, dark brown, dark brown is the color, is the end color of this. Dark brown. Moving on to the second question, second part of the question. Identify the reducing agent in this reaction. Explain your answer. Okay. Before I always tell when it's in about the question about oxidation and reduction, you need to be familiar with the definitions. Okay, so firstly clear the first step. Be familiar with the definitions. Okay, you need to be thorough with all topics if you are studying for grade 10, if you're studying for IGCSE. Okay, so you just firstly learn them, learn them, learn them until you are perfect. Okay, because this time we were lucky not have the IGCSE exam in the hall, but we're lucky enough to have the IGCSE exam in online. But next time we won't be lucky, I think so. Yeah, because COVID-19 is, I think is, I pray that it is hopefully over by next year and we can give our exams for AS. Our students can give exam for AS, IGCSE, A levels. We'll just pray, then we'll see, inshallah. Now, moving on to this part of the question, identify the reducing agent in this reaction, explain your answer. I'll tell you before, you need to be familiar with all the definitions. As you can see here, oxidation and reduction. Oxidation and reduction is here, I guess. Yeah, oxidation. Now, I always state that you need to firstly check the equation, what it's trying to say in terms of addition of oxygen. Now, I'll ask you one question. According to the question, what you need to mention here, which definition we should go for? Yeah, you were right. So we need to mention in terms of oxidation state. You can see here when oxidation occurs, the oxidation state of an element is increased. For example, if you go 1 plus 2 plus or 1 plus to 3 plus, it is increased, or from minus 1 to 0 or from minus 1 to 1 plus, like this. Now, the reduction, oxidation state of an element is decreased. This is the opposite of the oxidation. And one more thing you need to know here, when the oxidation state of an element is increased, this means it is becoming oxidized. And the element or the substance which is becoming oxidized itself, but it gets reduced itself. So it is called as a reducing agent. And when a substance is being reduced, okay, and it's doing so itself, it is oxidizing another substance. Okay, so we can say it's an oxidizing agent. Now, for example, I'll stay here. So to identify the reducing agent in this reaction, you can see here from I minus we are getting I0. Okay, from Cl2 we are getting Cl minus. Okay, here it's decreasing and the oxidation state here is increasing. Oxidation state is increasing for 2I minus, it is becoming I2. This means it is becoming oxidized and it is called a reducing agent. The answer for this question, simply first you need to, it's a 2-mark question, you need to mention the ion which is being oxidized. So we can say here iodide ion. Okay, firstly the first mark is for mentioning the ion which is becoming oxidized. We can write here iodide ion is becoming oxidized as the oxidation state of this ion. Sorry, I need to mention the reducing agent. I was confused. Iodide ion is the reducing agent, as the oxidation state of this ion of this ion is increasing. Okay, so whenever a substance is becoming oxidized, it is a reducing agent. Whenever it is being reduced, it is an oxidizing agent. Okay, this is simple. Now moving on to the we are done with the fourth question. Now moving on to the fifth question. Dilute hydrochloric acid reacts with sodium carbonate solution. Here the equation is given. You can see it. Okay. Explain why effervescence is seen during the reaction. Okay, what happened here? Now if you check the reaction, let me just tell you. This effervescence, this fizzing, these bubbles, why they are seen? Because what happens, these bubbles, these effervescence, this fizzing is seen because of the production of a gas. Now you can see here in product side, if you go, you can see sodium chloride is the aqueous salt, H2O we are getting as a liquid, and CO2. Carbon dioxide is a gas. So we can see due to the production of carbon dioxide, effervescence is seen. So I can simply write here carbon dioxide is produced. Carbon dioxide is produced. Okay, so B is an experimental question and also include moles. Question on moles. Oh, okay. We want to part B. Dilute hydrochloric acid was treated with a sodium carbonate solution. Here are the steps given. 10 centimeter cube of 0.100 mole per decimeter cube of hydrochloric acid is placed in a conical flask. Complete also methyl orange indicator. Add the dilute hydrochloric acid. The mixture was treated with a sodium carbonate solution. 16.2 centimeter cubes of sodium carbonate solution were required to react completely with the acid. We have read the whole question. Now moving on to the question. Moving on to this part of the question. What color would the methyl orange indicator be in the hydrochloric acid? If you don't remember, watch my previous video so you can just get off that. You can seek. You can just your doubts are over, so you're not left with any doubts. And not good with words actually, but I need to mention this. So what color would the methyl orange indicator be in the hydrochloric acid? As I said before, in the previous paper, that methyl orange indicator has only two variations. Okay, it is red or either it is yellow. Okay, what happens whenever it is placed in an alkaline medium? For example, if you're placing in potassium iodide or in another alkali or group, alkali is basically the bases. Okay, the group on oxides and hydroxides. Okay, so whenever you place a methyl orange indicator in these type of alkaline mediums, the methyl orange indicator would immediately turn yellow. But hydrochloric acid, okay, if you're placing in an acidic medium, it will turn red. Okay, these are the two variations you need to be familiar with. Okay, these type of questions are asked and they are often for 1 mark. You need to be familiar with the indicators and different indicators and what are the variations. I need to be familiar with each color. You need to learn that color pH, pick a pH color when at what pH it is what color. So we can say it's red in color for this question. Calculate how many moles of hydrochloric acid were used. Okay, remember it's a 1 mark question, but it's not a direct question. It's asked indirectly, so you need to firstly you need to mention some formula. So I'll mention the formula here. Basically, they're talking about moles. So number of moles they had in first statement you can identify which equation we can use. Okay, they are asking us for 10 centimeter cubed of 0.1 mole per decimeter cubed of hydrochloric acid. Basically the concentration and volume is given, so we need to write the equation as right number of moles equals concentration on oh, concentration times volume. Okay, now remember one thing. Okay, you need to check the units also. Checking the units, most of the students forget checking the units and they lose their 1 mark. Okay, they waste their 1 mark. So firstly, concentration you need to write as it is 0.1 mole per 0.1 mole per decimeter cubed. Okay, now times volume you can see it in centimeter cubed, and this concentration is mole per decimeter cubed. So to give the correct answer, you need to change the units. How will change the units? I'll convert this centimeter cube, the 10 centimeter cube, into decimeter cube. So how I'll do that? I'll just write 10 and I'll divide by 1000. Okay, because there are difference between 1,000 between the centimeter cubed and decimeter cubed. Okay. Now, if you just multiply this in your calculator, you'll get the answer as 0.100. Am I correct? Yeah. Times 10 over 1,000. 10 over 1,000. And you will get your answer as 0.001 moles. Okay. Your answer for this question will be 0.001 moles. And make sure you write the answer in the given provided space also, so your teacher, your examiner is not confused and you don't lose your precious 1 mark. 0.001. Moving on to part 3 of this question, use your answer to B2. Okay, B2 I'm using. Okay. And the equation to calculate the number of moles of sodium carbonate that reacted. Okay, it seems like it's very difficult, but if you read the question, if you understand properly, you can answer it very quickly without any difficulty, without any obstacle. Okay, so what we will do, firstly, what we need to do is, we know the moles of hydrochloric acid, and we need to calculate the number of moles of sodium carbonate that reacted. If you see here, we need to check, we need to firstly mention the molar ratio. Molar ratio is about what they're asking. Molar ratio for HCl, okay, HCl to HCl to Na2 Na2CO3. The molar ratio is 2:1. 2:1. You need to be familiar with the topic of moles for these type of questions, okay? Now, if you see, the moles of HCl were 0.001. 0.001. And we can write this 2:1 as 2 over 1. 2 is for, we can write here 2 over 1. 2 is for HCl and 1 is for Na2CO3. Sorry guys, Na2CO3. This means the moles of sodium carbonate will be half of the moles of HCl. So simply we can divide 0.001 divided by 2, which will be the answer as 0.0005. The answer will be divided by 2, and the answer we'll get is 0.0005. You can also check with the marking scheme and we'll get the same answer. Let's increase my working speed. Okay. Use your answer to B3 to calculate. Okay, so this time we should use this answer for moles to calculate the concentration of the sodium carbonate solution in mole per decimeter cube. Okay, so we have to answer this question. Okay, guys, it's a this I'll say it's a difficult question, but if you have the intention, good intention to answer this question, you can answer any question. So you guys are now going to do it that I told you before. To calculate this, you need two equations. Okay. The first equation, both equations are for the moles, but they are in terms of different units. The number of moles equals concentration times volume. Concentration times volume. Okay, now you can see here about sodium carbonate, what information we have. We have no information. Okay, we have just a single information. Let me just check if I'm not wrong. We have, guys, we have only, okay, we have it. Yeah, we have information. You can see in the last part of the this question, step 16.2 centimeter cube of carbonate solution were required to react completely with the acid. The volume has been given. The volume has been given, and the number of moles are also given, 0.005. And remember, you need to mention the mole per decimeter cube. So we need to answer the question in mole per decimeter cube. The answer should be in mole per decimeter cube. Okay, so now we need to just rearrange the equation. We need to just play with some equations so we can get the exact thing. Basically, we are finding the concentration of sodium carbonate solution. So what we'll do, if we rearrange the equation, Okay, guys. So now we should use the equation. We can rearrange the equation now. So concentration, we are finding the concentration. So concentration equals. Actually, there were not two equations, but because I was just I don't know whether the volume is given or not, but the volume was given. So we'll use only one equation. So concentration equals moles over volume. Okay. Now what we need to do, we have the number of moles as 0.005. You can see from the part 3, which is calculated for sodium carbonate solution. And volume they have given us in centimeter cube, which is I think it's 16 centimeter cube, right? 16 centimeter cube, 16.2 centimeter cube. We need to convert this into decimeter cubes. So what we will do now, into 16.2 over 1000. Okay. So how we'll write this as we need to divide the molar of moles by the volume. 0.0005 over 16.2 over 1000. The answer for this question will be 0.03. Yeah, 0.031 also you can write, and 0.03. Let me use like the marking scheme. So how will write this answer? Your answer should be to, I think it should be to 1 2 3 3 dp. Okay, so your answer should be to 3 dp. The answer for this question will write as 0.0031. 0.0031, not 0.00, 0.031. Yeah, now it's correct. Okay, in another experiment, 0.20 mole of sodium carbonate will react with excess hydrochloric acid. Calculate the maximum volume at RTP and room temperature and pressure of carbon dioxide that could be made in this reaction. So here we can use the equation for volume equal moles times 24. Okay, I'll tell you how we'll use the equation. You might be thinking that we don't have the moles, how we'll use that equation. I'll clear all the doubts here. Volume, firstly I'll write the equation here. Volume equals mole times 24. Now what can they have given here? They have in another experiment 0.02 moles of sodium carbonate were reacted with dilute with excess hydrochloric acid. Okay. Calculate the maximum volume of at RTP of sodium carbonate gas current of carbon dioxide that could be made in this reaction. So you can see here the equation is similar. The equation is similar. Okay. So what we could do now, we know that they have given us the moles of sodium carbonate, but they didn't give the moles of carbon dioxide. So we can use here the molar ratio trick. So what we could do, the molar ratio is 1:1 because there is no number here, so we can write here 1, and there's no number here also, we can also write 1. So your molar ratio will be 1:1. I can write here as the answer, the molar ratio equals 1:1, 1:1, which will be equal to, okay, so the moles are, so 1:1 means if there is one mole, if this 1 represents the moles of sodium carbonate, which is 0.02, this means this is same as the moles of carbon dioxide will be same as the moles of sodium carbonate. So the answer for the moles of carbon dioxide will be 0.02. Okay, this we got the moles. Now we can input the equation here. Okay, so we can write here volume equals moles we have got as 0.02 and times 24. Now if we write this equation 0.0 times 24, we get 0.48. Okay, make sure if you're writing in decimeter cube, you will write 24. If you're writing in centimeter cube, you write 24,000. Okay, but this time it is in decimeter cube, so we'll write as 24. So we'll get our answer as 0.48. So right here also our answer as 0.48, 0.48 as the answer. Okay. Moving on to the sixth question. Concentrated ammonia solution gives off ammonia gas. Concentrated hydrochloric acid gives off hydrogen chloride gas. Ammonia NH3 and hydrogen chloride HCl are both colorless gases. Ammonia reacts with hydrogen chloride to make the white solid ammonium chloride. So you can see here the positions we have to basically determine. Okay, cotton wool soaked in concentrated hydrochloric acid and cotton wool soaked in concentrated ammonia solution. Okay, now they're asking, after 10 minutes, a white solid forms in the tube where the gases meet. Write the chemical equation for the reaction of ammonia with hydrogen chloride. So firstly, chemical equation, 2 marks question, 1 mark question. But I prefer balancing the equation. Okay. So you can see here, let's go to the question. Just a minute. Yeah, so this is the equation for this one. So it is already balanced. No need for writing the words here. It's already balanced chemical equation. So I just write as it is here. Okay, name the process by which the ammonia and hydrogen chloride gases move in the tube. You can see here, actually where the cotton wool is present, it contains, there is a higher concentration gradient. And what happens in whenever gases are involved, actually these are gases, and they are always gases move to diffusion. They are moving from a higher concentration gradient from to a lower diffusion gradient. They are going like they are going. This is going to the left side. Is going to the right side. This one is going to the right side. Is going to the left side. So they are moving to a different area, but where there is low concentration. So we can say diffusion is occurring. Diffusion is occurring. Diffusion. Okay, done. Now, part 3 states that at which point A, B, C, or D does the white solid form? Explain why the white solid forms at that point. Okay. Firstly, before you solve this question, you need to calculate the molar mass of both hydrochloric acid and cotton and the ammonia solution. Okay, NH3 you need to calculate and HCl you need to calculate. And if you compare their molar masses, you can see that ammonia has a lower mass and HCl has a faster as a is heavier than ammonia. What does this mean? Now, if heaviness and lightness will determine like which will move fast. Okay, so if ammonia is lighter, this means it will move fast. Okay, common sense. And if HCl is heavier, it will move slowly. Okay. So if we see this position, if we see the test tube again, glass tube again, you can see this ammonia solution is present here. It is running fast and this is running slow. Okay, this means this can reach in at A faster than this hydrochloric acid. So we can say at A the white solid forms, and why this forms, I'll tell you why. Just move down. Yeah, guys. Yes, we can write here the white solid forms at A because NH3 has a lower mass than HCl, so will diffuse faster. Right, we're done. The experiment was repeated at high temperature. Predict how the results of the experiment will be different. Explain your answer. Okay, so answer for this question is a 3 mark question, but the answer is very simple. Okay, so what we need to say, the higher the temperature, if you increase the temperature, what happens? The movement of the molecules, the kinetic energy of the molecules will increase as they have more energy. And what happens? The white solid will form faster. Okay, but depending on the temperature, we can compare the time. If it is a lower temperature, the white solid will form slower. If it's a higher temperature, it will form faster. Okay, so this thing you can just write here. Just copy the statement. Copy. I'll just paste it here. A minute, guys. Okay, so this is the answer for this part of the question. Moving on to the next part of the question. Some of the white solid is removed from the test tube and dissolved in water. Okay, so this is the NH4Cl we are talking about. Describe how this white solid will be tested to show it contains ammonium ions. So actually, you need to be familiar with the identification of ions and gases. Unit. You need to be familiar with all the tests. So ammonium ions you can see here. If we add, okay, so ammonium ion presence will be if we add sodium hydroxide solution, it will produce ammonia. Okay, so I can write here my test that adding sodium hydroxide solution to NH4 Cl. What will happen now? The result for this, ammonia is produced. Okay, ammonia produced, ammonia is produced, and the condition if warm. Now test for chloride ions. Okay, so the presence of chloride ions will, how we'll do that? We just check. I just saw somewhere chloride. Yeah, if you see this, the test for this chloride ions is it will acidify with dilute nitric acid and will add aqueous silver nitrate. Okay, so the test for this is you can just learn the tables below and learn the table provided, and so you're familiar with all the tests. Okay, so what we'll do, acidify with dilute nitric acid, nitric acid, and add aqueous aqueous silver nitrate. Now what will be the result for this? Sorry. What document? White precipitate will form. Okay, this is the result. White precipitate forms. Okay, moving on to the part C. The diagram shows the electron arrangement in the molecule of ammonia, showing only outer shell electrons. State the type of bonding in ammonia. So it's between a, you can see nitrogen and hydrogen are nonmetals. So we can say if they're nonmetals, then covalent bonding occurs. But if it's a metal and nonmetal, then it's ionic bonding, covalent bonding, right? Moving on to the next part of this question, I need to be do it fast. Hydrazine N2H4 is another compound of nitrogen and hydrogen. Complete the diagram show the outer electron arrangement in a molecule of hydrazine, showing only outer shell electrons. You can see the similar diagram came in the previous paper which we did. Okay, so you can go to the previous video, okay, which was of the chemistry paper 0620, paper 42, Feb March 2016. You can see that video and you can refer to the diagram. I've already done the diagram, so you can just copy the diagram. You can see here the diagram. Okay, this is the diagram. Unfortunately, I just can't copy the image, so you can just copy from here. Okay. Okay. Now I'll move on to the part. Nylon and proteins are both polymers containing nitrogen. Name the linkages found in the polymers of nylon and protein. So the linkages, what if it is an ester link or amide link, we'll need to see. So nylon is a polyamide. It's a polyamide. Okay. We can see the last the okay. So what happens if you see this? Nylon is a polyamide made from dicarboxylic acid monomers. Okay, and we have diamines. Okay, so each this functional group will react with another NH2 group on the another monomer. Okay, and amide linkage is formed. Okay, so in both proteins and nylon, you can see an amide linkage is formed. Okay, so right here, amide linkage. Describe one difference in the structures of nylon and protein. Okay, to answer this question, if you see here, one difference what they have, I'll just tell you one minute. Okay, actually it's written in the notes. You can refer to say my exam notes and you can see there in the um, topic organic chemistry, the last part, the polymers, you can see that nylon protein is made from protein is made from more than this here. Protein is made from more than two monomers, and nylon is made from more than uh, made from one or two monomers. Yeah, actually, this statement I'm already always confused about this. Monomer. What is the general name given to product of hydrolysis of proteins? So if we hydrolyze proteins, the general name is given to the products as amino acids. Okay. Yeah, because if you break down proteins, obviously we'll get amino acids, right? You can also use some biology also to solve these questions. Here the selections of the monomer used to make the polymers. From the structure I will show you. Okay. So basically the structure for this question. Okay, 1 minute, guys. Actually, just give me a second. Because like this is the image. Actually, I will not able to draw properly because I need to do the handwritten I need to draw with hand. So I could not draw in the PDF file or in the Word document. So this is the diagram for the uh, structure, which is asking about this question. This is the structure of the monomer used to make the polymer shown. And the polymer I have already shown here. This is the polymer. This is the monomer structure. Okay, so this was the end of the 06 to 43 May 2016. We'll meet inshallah in the next video. And don't forget to like, subscribe, and share the video and comment on the video. I'll go to comments later. And we'll meeting again with a new video. Till then, thank you and have a nice day.